Okay, catalytic reactor design. So the first example, we look at the catalytic reaction in slurry reactor. A slurry reactor contains 100 micron diameter spherical particles. So slurry reactor, we can model it as a CSTR. Okay, model as CSTR. And it contains 100 micron diameter spherical particle. So the diameter of catalyst spheres is 100 micron. So later you need to change the unit. And then catalyze the reaction A to B with a rate. So given the rate at the surface of reaction. Okay, R prime equal to 10 negative 3 Ca in moles per centimeter square per second. So the unit of R for the rate reaction at the surface is given as this. Okay, this is the unit. With Ca in moles per liter, the concentration unit. There are 10 power of 5 particles per centimeter cube. So maksudnya total particle of catalyst that occupy the reactor is 10 power of 5. And only the external surface of the particles is catalytic. Meaning that the active surface of catalyst only at the surface. Therefore, the reaction only occur on the surface, external surface of catalyst. Okay, itu maksud ayat yang tu. The concentration, which is initial concentration, Ca0 moles per liter in moles per liter equal to 2 and can be processed in a 10 liter reactor. So total volume of reactor is 10 liter with the conversion is 90%. Determine the volumetric flow rate of reaction. So the question asks you to calculate the volumetric flow rate. Okay, first what we need to do, list out what are given in the question, what are the value that we need to calculate. Okay, first, a slurry reactor. So we write the model equation. Slurry reactor can be modeled as a CSTR. So write the mole balance of CSTR. So Ca0 minus Ca per tau equal to R. So this is the mole balance equation for slurry reactor. Okay, and because the question asks you to calculate the volumetric flow rate, so automatically it will related with space-time. So, tau equal to volume of reactor divided with volumetric flow rate. Okay, next we need to write the pseudo-homogeneous rate because from the design equation here, so mole balance equation, this is the pseudo-homogeneous rate. So next, write the pseudo-homogeneous rate equation. So the equation is R equal to A over V rate reaction at the surface because reaction only occur at the external surface. Okay, therefore, number 3, reaction at the surface. Okay. Wah. reaction at the surface R equal to KCA. Okay, so this is all the equation that we are going to solve. Okay, then we need to determine what are the value that given in the question and what are the value that we need to calculate by ourselves. Okay, given the diameter of one spherical catalyst 100 micron, but overall we have 10 power of 5 particle catalyst. Okay, for spheres, surface area ataupun area of spheres, so you need to remember the formula is 4 pi r square. Okay, given diameter of catalyst is 100 micron, then change the unit to cm. Why? Because if you look at the unit of rate reaction and also the total particles that occupied the total particles that occupied the reactor, all in cm. So here in cm, rate reaction in cm, so we change the unit micron to cm, which is equal to 0.01 cm. Okay, now we can calculate the total area. So for one particle A equal to, so change because given here is diameter, so 4 pi diameter is d over 2 square. Okay, so continue in next page. So area of for one spheres equal to pi d square, which is equal to pi 0.01 power of 2. Oh, unit jangan lupa tulis centimeter and power of 2. So total particle that occupy the whole reactor is 10 power of 5. Okay, total particle 10 power of 5 per centimeter cube. So this is the total catalyst that occupy the reactor. Therefore, A over V, okay, from the pseudo homogeneous rate equation, the term A over V equal to thus A over V equals to pi 0.01 centimeter square multiply with 10 power of 5 particles per centimeter cube. And so you will get the value is 31.42 with the unit of centimeter square per centimeter cube. So if you look at the unit here, unit of area is centimeter square and unit of volume is centimeter cube. So this is A over V value, because the unit here is referring to the unit of A over V. Okay, next we need to look at the pseudo homogeneous rate. Okay, so from pseudo homogeneous rate equation, R equal to A over V R prime. Now A over V value, we already have this value as this one. R, this value given in the question, which is R equal to 10 negative 3 CA. So just insert into the equation. Therefore, 31.42. So write the unit to ensure that we will get the correct unit later. cm square per cm cube multiply with 10 negative 3 CA, and the unit is in moles per centimeter square second. Right. So this is your pseudo homogeneous rate. Okay, where this value, the 31.42 multiply with 10 actually equal to rate constant of pseudo homogeneous reaction. So R actually equal to KCA. So CA here similar with this one. K value, the value in green table. So this is the rate constant value for pseudo homogeneous rate. Okay, then we relate it with the model equation. From model equation, so CA naught minus CA per tau equal to R. R here is pseudo homogeneous rate, equal to KCA. So K value, the value in the green table, and then we know that tau equal to volume of reactor divided with volumetric flow rate, because we need to determine the volumetric flow rate. Okay, and for CA, CA naught 1 minus X. So X given, so this one given, which is X equal to 0.9, and CA naught also given, which is 2 mole per liter. Okay, then you can rearrange the model equation. So CA naught minus CA naught 1 minus X per volume of reactor divided with volumetric flow rate equal to K CA naught 1 minus X. Then rearrange, you will get volumetric flow rate equal to VR per CA naught minus CA naught 1 minus X multiply with K CA naught 1 minus X. Okay, then you will get the volumetric flow rate value. Next example is for the catalytic reaction occurs on the walls of a tube. Okay, catalytic reaction of A to B, again, we assume for one reactor is first order reaction, but the reaction occurs on the wall of tube reactor. Therefore, there is no a bed of catalyst inside the reactor. So, the reaction only occur on the wall of reactor. So, kalau tube we consider, so walls of tube is cylinder. Okay, cylindrical reactor. 1 cm in diameter. So, the diameter of the reactor is 1 centimeter with a flow rate of 0.1 liter per second. So, volumetric flow rate given as 0.1 liter per second. The rate of reaction at the surface of the wall, because reaction only occur on the wall, meaning that the reaction only occur on the external surface of catalyst. So the reaction is 5 times 10 power of negative for Ca, with Ca in moles per liter. So you need to be careful with the unit. Okay, so if you look at the unit of R, rate reaction at the surface is mole per centimeter square second, but the unit of concentration is in moles per liter. So later when you are doing the calculation, we need to standardize the unit. Assume diffusivity dA equal to 0.1 centimeter square per second. Determine the length of the tube to obtain 95% conversion if the concentration is uniform across the tube. So, we need to determine the length of the tube for 95% conversion. So, again, for cylindrical reactor, we can model the reactor as a PFR. So reactor model as PFR. Therefore, the mole balance equation or design equation is for PFR. dCA per dt equal to R. Okay, so R here is pseudo homogeneous rate. Or you can write it as negative dCA per dt equal to negative R. Okay, but negative sign actually referring to the disappearance of reactants, not the value of rate reaction. Okay, then next we write the pseudo homogeneous rate. So first step, reactor model equation. Second step is the pseudo homogeneous rate equation. R equal to A over V. R prime given as 5 times 10 power of negative 4 Ca. Okay. So kembangkan as A over V K prime Ca. So this equation that we are going to solve later, and also this one. Okay, these two equation. Right, now we look at the value given. Okay, so A, area of cylinder equal to 2 pi RL, the formula, okay, for the area of cylinder. And the volume of cylinder, pi R square L. And R prime given 5 times 10 negative 4 Ca mole per centimeter square second. But the unit of Ca is in mole per liter. Okay, then we solve for A over V. Okay, A over V equal to 2 pi RL divided with pi R square L. It's equal to 2 over R. Okay, given the diameter 1 cm, thus R equal to 0.5 cm. Okay, therefore dCA per dt equal to A over V. So, or you can insert the equation that we already simplify. So, dCA per dt A over V equal to 2 over R multiply with K prime Ca, which is this equation is equal to this equation yang ni. Therefore, here multiply with 5 times 10 negative 4 Ca. Now, we need to consider the unit. Right? Okay, so we want to change the unit. dCA per dt equal to 2 over R. R is 0.5 cm. Multiply with 5 times 10 negative 4. The unit, actually you need to check it ataupun determine the unit of K by using backward calculation. So, you will get the unit is liter centimeter square per second. Multiply with 1000 centimeter cube per liter, because 1 liter equal to 1000 centimeter cube. Multiply with Ca. This is because why we need to multiply with 1000 centimeter per liter, because the unit of Ca given is moles per liter. So we want to change the liter to centimeter cube. Barulah kita boleh cancel out the unit. Right, so solve this equation. You will get dCA per dt equal to 2Ca. Okay, now we can solve the integration. So dCA per Ca equal to 2 dt. Then you need to integrate it from Ca to Ca naught. Why from Ca to Ca naught, not Ca naught to Ca? Because dCA per Ca that we use here is positive. Okay, but this one should be no problem. Or you can write it as negative dCA per Ca. So integrate from Ca naught to Ca equal to 2 dt, 0 to t. Okay, then solve the integration. You will get, kalau saya guna yang negative ln Ca per Ca naught also equal to negative ln Ca naught So we can cancel out ln 1 minus x equal to 2. So solve the integration for 2 dt, you will get 2t. Okay, then 2t for t is equal to volume of reactor divided with volumetric flow rate. So the volumetric flow rate given in the question. Okay, so volumetric flow rate is 0.1 liter per second. Again, you need to check the unit. So multiply with 1000 centimeter cube per liter to change the unit. Okay, then insert this T equal to VR over V into this equation. Then you can solve it for length of reactor, because VR equal to, so the volume of a cylinder, pi r square L. So the question asks you to calculate L. So insert this equation into this one. Okay, then rearrange. Finally, you will get the length of reactor. So the answer is length equal to 190 centimeter.